going to be a little similar to some of the things that other things that we've talked about. So I call it similar figures, similar polygons. Figure just means shapes, right? Polygon means many sides. So they're just lots of shapes. So when two polygons have corresponding, what does corresponding mean? Matching. So matching, like we did when we were talking about triangles. Corresponding angles that are congruent and corresponding sides that are proportional. Proportional. All right. So the important thing here is the proportional part. So we talked about congruent figures. Congruent figures are exactly the same. So if we look at, because I'm looking at the back of you, if I look at Isaiah and Clay, and I tell you that they are similar. So Isaiah and Clay are in the far corner over by the blackboard. What does similar mean? If I tell you that right now Isaiah and Clay look similar, what am I saying? They look alike. They look the same, except similar means like not quite the same. Like they're not identical twins, right? They just look similar. They have some things in common. They're both wearing black hoodies. They both have brown hair. They both play football. They're both over there in the corner. Like there are some similarities, but they're not identical. So similar is like saying you have two of the same shape of different sizes. So there are some things that are exactly the same, the angles that are congruent, but some of them have a relationship. So another way to think about that is polygons with the same shape, but different sizes. So those are the two definitions that we're going to use for similar figures. They have corresponding angles that are congruent and corresponding sides that are congruent or that are proportional. Okay, Jose, you got to sit someplace else because you're late. Sit behind Clay. All right. So let's look at this first polygon. Okay, so the first thing I want you to notice is that what shape are those things that I drew? They have a name. What are they? Are they squares? Rectangles? Quadrilaterals? Are they quadrilaterals? Yes, they are quadrilaterals because they have how many sides? Calvin, how many sides? 4, which is called a quadrilateral. They have another name that's more specific. These two sides are parallel. When you have a quadrilateral with one set of parallel sides, it is called a trapezoid. So knowing the names of shapes is important. So we're going to, Owen, I want you to name the first polygon. You pick the order. Owen. I'm talking to you. Name the first polygon. Give me the names of the letters in any order you want. A, D, C, B. A similarity statement is where we name them like we named triangles before with the same order. That symbol means similar. So one little squiggle means similar. So now, Daniel, you name the second one in the same order. Not yet? All right. Malia, can you name the second one? If Owen said A, D, C, B, how do we name the second one in the same order? Yep. E, H, G, F. Now, I don't usually write a little nothing in front of that because it's got 4 sides. We will put triangles. So triangle ABC. I don't know why we don't for anything else except that it gets too hard to write all the different shapes, I guess. But ideally, this should have been in one line. A, D, C, B is similar to E, H, G, F. And it just means that those are the things. That means that I can look at this name, just like before, and see that angle A should be congruent to angle E. So angle A is congruent to angle E. That's one of the requirements, is they have to be the same shape. So then angle D is congruent to angle H because we have the second letter in our set. Angle C is congruent to angle G, and angle B is congruent to angle F. So that's all those symbols mean, is that this, either from the picture by looking at the symbols or from the name, I can tell you which angles are congruent, either looking at the symbols in the picture or looking at the order of the name. So now we do corresponding sides. And again, order is the most important part about this. So if I call it AD, because I said AD like this, it needs to be EH. AD in that order and EH in that order. They have to be the same proportion. That's another name for a fraction, a ratio, or proportion. They have to be the same on all 4 sides. So then DC over HG, CB over GF, and BA over FE. Look at where the letters are side by side. You can kind of see how that has to go together. It just helps you keep them in line. So we just went counterclockwise around our shape. This one doesn't matter. This one does because it has to relate back. So you get to pick the order of the first shape and then just make sure that the second one matches or corresponds. So the first thing we have to do is determine that all of the angles are congruent. Sometimes that's easier than other times. And then once we do that, we have to determine that all of the sides have the same relationship, the same proportion. So let's go through and do that for these 2 examples. So when we first look at this, I'm going to ask whether means if those figures are similar. So I don't know yet. I'm just looking at pictures and I need to determine that. So I'm going to say, is ABC similar to D, E, F? I don't know. That's what we're doing. That's the whether or not it is. So that means that angle A has to be congruent to angle D. Those are the first ones, so they got to be. So what's angle A? Angle A is 30. Is angle D 30? Here's 30. Here's 30. Yep, we're good. So then we have to say angle B has to be congruent to angle E. I don't know what angle B is, and I don't know what angle E is, but I can figure it out. What does a triangle equal? 180 minus 90 minus 30 is 60. So this one is 60. And since this has a 30 and a 90, this needs to be 60. So now I can say that B and E are the same because they're both 60. And then I can say angle C is congruent to angle F because they're both 90. So far, the first set of criteria matches. All of the angles are the same. So we're good. Now I have to look at the sides. So I'm going to look at AB compared to DE. Oh, hold on just a second.
Are these the answers? How you're supposed to answer
That's
from?
fine. AB, so we went from 30 to 60. So from 30 to 60 over here is DE. We want to keep the same order. That has to be, but I don't know yet if it is, equal to BC compared to EF and CA compared to FD. So then we're going to go through and make the fractions. So that's 12 over 9, 6 over 4.5, and 6 square root of 3 over 4.5 square root of 3. So I had students ask yesterday asking me how to use the calculator, how to put in square roots and stuff before a test or on a test. At this point in your school year, let alone your academic career, you should be able to do square roots and fractions without asking how to do it. If you don't, it's because you're not practicing enough. Because right now, I need to put each of those in the calculator, 12 fraction 9, and then change it to a decimal. And when I change it to a decimal, I get 1.33, repeating. 6 divided by 5 is 1.33, repeating. And 6 square root of 3 divided by 4.5 square root of 3. Let's just use some common sense. Anything over itself is 1. This is now 6 over 4.5, so it's the same thing. So I get 1.33 repeating. Therefore, this symbol means therefore the sides are proportional. So I can say triangle ABC is similar to triangle DEF. But you have to prove it. You can't skip this step or this step if the angles are not obviously all the same. You have to prove that every angle in the right order. Because if I turn this around and said, is triangle ABC similar to triangle EFD? That would be a no because of order. Because A doesn't match E. A and E don't match. So it has to be the order that you're looking at. Just like for congruent, not in that order. So let's look at one that doesn't have a triangle. Osvaldo, can you name the first polygon? Doesn't matter what you call it, you get to pick. A. It does have to go in order. So A, B, like this way order. C, D, okay. So you could have picked any letter to start, but then you have to go one at a time. Does that make sense? So that's it. Sorry to pick on Osvaldo, but that's a good thing to know. You can name it in any order that you want. So I could start at D and go around either way, but I have to go to the next one. I can't skip back and forth because it just doesn't work that way. So I want to know if it's similar to, so which one matches? So since we said, can you close the door, Anthony? Since we said A, B, C, D, then we're going to go with E, G, E, F, G, H. Anthony, can you close the door? So I'm trying to see if they're similar. So first, the angles have to be congruent. Are the angles congruent? They're all right angles. All right angles are the same. They all equal 90 degrees. So all of our angles are congruent. That's the first criteria, the first thing that has to be true. So then the next one is that my sides have to be proportional. They all have to have the same relationship. So in the sense that you are all students, you are all proportional because you're all, the relationship between students in this class is the same. But if we start talking about, are you all sophomores? Are you all male? Are you all female? Then we start to get some not similarities, right? So for sides, based on our shapes, we're going to have to say AB compared to EF has to be equal to BC, CD, DA compared to FG, GH, and HE. And they have to all be the same. This is the important part. Are they the same? We don't know yet. So then we look at AB. So AB is 7 and EF is 6. Now, when you first look at this, you think, well, why can't they be the same? The long side is one more than the short side. That's the same thing over here. The long side is one more than the short side. They're not the same, but these two are the same and these two are the same. And these two are the same and these two are the same. And then the change here is just 1. So when you first look at it, you're sure, they could be the same, right? They could be similar, but you have to do the math because as you'll see, these are not. So this equals maybe 6 over 5, 7 over 6, and 6 over 5. Now right away I can see that I have two sets of sides that are the same. So they're the same then, right? The only way to check is to put that in the calculator and see that this is 6 repeating, and this is 1.2. Now, if we were rounding, this would become 1.2. The 6 makes the 1 go up, but we're not rounding. We're looking for exactness. Are those the same thing? They're almost the same, but are they the same? They are not. So this sentence right here, math sentence, says not equal, therefore not similar. because the proportion is not the same, they are not similar. So they just have to be the same. So when you're looking at your assignments later, you have to find the relationship between the sides, just like I did by naming the sides and determining that each piece has the same relationship all the way around the shape. Whether it's got 3 sides or 10 sides, it has to be the same all the way around. After you find that number, so in this case, it's 1.33. After you find that number, that is called your scale factor. And scale factor is the ratio to the lengths of the sides. Now it says any two, so you think, okay, I can just pick 2 sides. No, no, no. 2 corresponding or matching sides. Scale factor depends on the order of comparison. Are we going small to large or large to small? It matters. So when we look at these pictures in this example, I want you to notice the difference between questions A and B. So the first thing, given that A, B, C, D is similar to E, F, G, H, I just told you that all the angles are the same and they have the same proportion. I'm telling you that they are similar. They meet those 2 criteria. Sides are proportional, angles congruent. That's what this statement means. Now I want to know the scale factor based on size. So comparing big to small, I'm going to pick AD, which is the first and last letter, which means I have to compare it to EH. AD is 6. EH is 3, so my scale factor is 2. That means that AD is 2 times as big as EH. That makes sense. 6 is 2 times as big as 3. Okay. But using those same 2 pictures, when I change the order, because now we're going small to big. Now I'm going to pick EF and AB. EF compared to AB, EF is 3.5 and AB is 7. That's now 1 to 2. That means that EF is half as big as AB. It's not hard. It just requires that you pay attention to the order. Like so many things that we've done this year, order is the most important thing. Now let's give it a couple of tries. This one says that we are going from small to large. So since all of us read English or a Latin language, we read from left to right. So your first inclination is to go like this. You just need to make sure that that's the small to big. Sometimes it is and sometimes it's not. So when we look at that first quadrilateral, 4 sides, Can I say that 18 matches anything? Does 18 match anything? No? So I can't use 18 because there's nothing there. So these shapes look like they're oriented or situated the same way. So I'm just going to say that 24 matches 40. And when I simplify that, that's 3/5. So that means that for every 3 units in the small one, I go 5 units in the bigger one. When you do the second one, it's the same process. So 25 small over big, 25 over 30, that's 5/6 is my scale factor. So to prove it, you take 25 divided by 5/6, and that should equal 30. That's how you do it as you're doing the math for that section to figure out that you have the right one, okay? This isn't difficult. You just need to pay attention to order and make sure that you are matching the corresponding parts.